Okay, this is Dr. Williamson. I'm going to continue with that little trick that I showed you where we took, like 45 grams per mole is the same thing as 45 kilograms per kilomole, or 45 grams per mole is the same thing as 45 milligrams per millimole. Here I'm going to do a stoichiometry calculation that we're going to use a similar trick. So down here in the bottom, I have an Erlenmeyer flask that has 20 mils of sulfuric acid, H2SO4. Those are subscripts 2 and subscripts 4. And I titrated it to the end point with 0.1002 molar sodium hydroxide. The starting volume was 0.37 mils. The final volume, when I reached the end point, saw that just started to see the indicator change color. And that volume is 42.58. The volume that I dispensed will be, that's these blue drops that fell out. And it's 42.58 minus 0.37 equals 42.21 milliliters of sodium hydroxide dispensed. What is the concentration of the sulfuric acid that was in here to start with? So what I'm going to do is the reaction is in between these two, this and this, so I can ignore these guys for now. It's between those two. And I'm asking, if I know this, what's the concentration of that? So if I go ahead and do that, I'm going to go, I have here dispensed 42.58 milliliters of 0.1002 molar sodium hydroxide, and 0.1002, that's 0.1002 moles per liter, but that's the same thing as 0.1002 millimoles per 1 milliliter. So I don't even have to convert this from milliliters to liters. I can convert this into millimoles per milliliter. And then when I look at the balanced chemical equation, for every 2 moles of sodium hydroxide, I get 1 mole of sulfuric acid. I can do that. I can say for every 2 millimoles of sodium hydroxide, I will need 1 millimole of sulfuric acid. And that'll give me, I need a millimole in here. So let's see here, eraser, fix that. I'll put my milli right in there. Sloppy, but you guys get it, right? Millimoles, boy, that's really bad penmanship. So if I were to type this, I'll go ahead and type it. That would be the same thing as 42.58 milliliters times 0.1002 millimoles of sodium hydroxide per 1 milliliter of sodium hydroxide times 1 millimole of sulfuric acid, H2SO4 per 2 millimoles of sodium hydroxide equals, just to kind of clean up the penmanship there. And if I do that, I'll go back up to over here. I'm going to go 42.58 times 0.1002 equals, divided by 2. That's going to give me, here, let me just double check, 42.58 times 0.1002 divided by 2. I'm going to get here 2.133 millimoles of sulfuric acid. Okay. But I wanted to know the original concentration. So to get the original concentration, molarity is moles per liter, but that's the same thing as millimoles per milliliter. So I have 2.133 millimoles of the sulfuric acid over 20.00 milliliters of the sulfuric acid. That's going to give me 0.1067 millimoles per milliliter, and that'll be the same thing as 0.1067, right? 67 molarity H2SO4. Again, sloppy penmanship, but the point I wanted to show you was that if I just realize 0.1002 molarity is 0.1002 moles per liter, which is the same thing as 0.1002 millimoles per milliliter, then I can do everything in terms of millimoles and milliliters. So I took my bad penmanship, 42.58 milliliters, in 0.1002 millimoles per milliliter. That's the same thing as 0.1002 molarity. And then the mole ratio here is 2 moles of this for 1 mole of that, or 2 millimoles of this for 1 millimole of that. That gives me 0.2133 millimoles of sulfuric acid. If I want to know the original concentration, I'm going to take the millimoles divided by the original volume, which is milliliters. I can keep everything in millimoles and milliliters. And I'll get 0.1067 millimoles per milliliter, which is the same thing as 0.1067 moles per liter, or 0.1067 molarity. So I just wanted to show you that trick. Again, I'm sorry for the poor penmanship, but you understand what I'm doing. Okay, all right, then I hope that helped.